Hello everyone, welcome to EC404 College. I am Shamim and today we are going to exploring the intriguing world of cryptography. Specifically, we will be delving into the Caesar cipher, an ancient but powerful encryption technique. The Caesar cipher is one of the earliest known encryption methods, dating back to Julius Caesar's time. It's a substitution cipher where each letter in the plain text is shifted a fixed number of position down or up the alphabet. In the encryption process of this algorithm, we need to pass our plain text through our encryption algorithm, and this algorithm will need a shift key value and process our and give us a ciphertext value. And on the other hand, for decryption process we need to put through our ciphertext into a decryption algorithm, and this algorithm also needs a key value, and this process will give us a plain text. For example, imagine we have the alphabet laid out in a line with a shift key value 3, where A becomes D and B becomes E, and so on. For this example, if we take a plain text as hello, then we'll get a ciphertext like this, where H become K and uh, E becomes H, L becomes O, and O becomes R. So this KHOOR will be our encryption message for hello. Now in the encryption process there are actually two ways. For one, if our ciphertext index value uh, becomes greater than 26, then we need to uh, follow a single process. Let's tell this process as A. We need to follow process A if our ciphertext index value is greater than 26, and in second way, if our ciphertext index value is in the range of between 1 to 26, then we'll follow process B. So for the initial stage, let's go for the process B, and after giving an example of process B, we'll give an example of process A. Okay, for both process A and B, we just need to remember these two equations. In this equation, uh, get the value of ciphertext index, we just need to add our plain text index and key value, and in order to get our plain text index value we just need to subtract the key value from our ciphertext index value. So let's go for our encryption process, where we take Apple as our encryption message, and let's just say we have 5 as our key value. Okay, so 5 is our key value. Then here we write down our index value from A to Z sequentially from 1. Here A equal to 1, B equal to 2, and so on. According to this index value, S index value will be 1. For P we will get index value 16 for plain text, and this P is also 16, and for L we will get 12, and for E we will get 5. So now we need to get this ciphertext index value. So how will we get ciphertext index value? We simply just add plain text index value and key value. So our plain text index value is 1, and our key value is 5, which is 6. Similarly, 16 plus 5 equal to 21, and 16 plus 5 is again 21, and 12 plus 5 will be 17, then 5 plus 5 will be 10. Okay, so right now let's see, 6, it is between range 1 to 26. So if we find this kind of situation, we just need to write down the exact value of this index, which is f. And again, 21 is the range between 1 to 26, so we just need to write the value of this index, which is u. Similarly, again u, and say for 17 we need to write q, which is between 1 to 26, and for 10, which is again between 1 to 26, so we need to write down j. So for Apple, if we put our key value as 5, then we'll get FUUQZ as our encryption message. Now let's give another example of encryption process. For example, we again again put our plain text as Apple, but and let's put the index value first. Okay, so for A our index value will be 1, for P our index value will be 16, and for P 16, for L we'll get 12, for E we get 5. Okay, so for in this case let's think our key value as what should we do? Let's think our key value as a random number. Okay, 3157 for each one. 3157. Okay, okay, so 570. Now how will we get our ciphertext interval? We just need to add plain text and key value, which is 57 equal to 3158. Similarly, this is also 3173, then 3173 again, and this will be 3169. 3169, and this will be 3162. Okay, now what we'll do, we previously saw that all our ciphertext index value is in the between the range of 1 to 26, so we can directly get these values from A to Z. Okay, but now we have a value of 3158, so we don't have any alphabet which is index value is 3185, right? So what we need to do here is, first we need this ciphertext in value, which is 3158, and divided it by 26, because we have 26 alphabet here, so we need to divide this with 26 If we do this, we'll get a result, which is, for example, let's go to our calculator. Okay, let's open our calculator and write down 3158 divided 26. Now we get a fraction value. See, this is our fraction value. Okay, this is our fraction value. Okay, this is our fraction value. Now we just need this fraction value and multiply it with 26. If we do this, then we'll get a value which is, let's do it again. Okay. 3158 divided 26 minus 21 into 26. Okay, we get 12. Okay, we get 12. So we need to write here 12. Similarly, we will find all the other value which are 1, 1, 2, 3, 16. Now we get again all the value between 1 to 26 range, right? So all we need to write down the value of that index. For here 12, 12 index value is L. Okay. Again 1 is A. For 23 this is W. For 16 we got P. So LAAWP is our index, our encryption message or ciphertext. Now let's see an example of decryption. We are going to decrypt this message here. Okay, a message here, so we can get after decryption we can get the result of Apple. If we get the Apple result after decrypting this message, then we'll be sure of it that our algorithm is correct. If we don't get this Apple result here, then we will be pretty much sure that our algorithm is incorrect. Okay, so let's do our decryption algorithm, where we will use LAAWP as our ciphertext and 3157 as our key. Okay, so we put it down the LAAWP as our ciphertext and 3157 as our key. Okay, so now let's put the index value of LAAWP. It is 12, 1, 1, 1, 23 and 16. Okay, so now let's get the pi value. So previously we saw a equation where the pi value P equals to C minus K. Okay, so let's minus from 12 minus 3157 will be negative 3145. Similarly, this will be 3156, again 3156. This will be 3134 negative, and this will be negative 3141. Okay, so previously we knew if this value here is between 1 to 26, we know how to find the answer, right? We just need to write down the value of those indexes, then we will get our plain text or ciphertext. Okay, so if our value become value become greater than 26. Okay, so we know how to do that in your encrypt we learned how to do that in our encryption process. Okay, but in here we get none of those. Okay, we get a value, negative value, less than which is less than 1, which is less than 1. Okay, so how will we solve this problem? In order to solve this problem, we need to see a equation where pi equal to y. Okay, y plus third bracket 26 into second bracket positive py. What is positive py? Positive py is this value. We get negative, we make this into a positive value and divided this into 26 and plus f. Okay, so after dividing py by 26, if we get anything fraction value, okay, if we get any fraction value, then with this equation we'll just put enough number in this f so that we get the next integer value. Okay, so this is, if we get any fraction value, we will count next integer value. Okay, for example, if we get 1.1, okay, we'll count this as 2 in this particular position. Okay, so if we get 3.99, we will count this as 4. Okay, this is why we write down plus f. So and why this y will be directed this pi value. Okay, so let's do this. So according to this first one, 3145, this is our plain text index value, plus we got 26 into, so if we divided 3145 divided by 26, okay, 26, then we will get, let's see what we get. We will get 3145 divided by 26. Okay, we get 120.96. Okay, 120.96, 120.96 value. Okay, okay, so now we get a fraction value. Okay, so we add 0.04 here, 0.004, so that we can make this 120 value into its next integer. Okay, so this whole thing will be 121. According to the equation, this whole thing will be 121 now. 121. Okay, so this equation we will get 121, and now we will multiply this 121 with 26, then we will get 3146 as a result. Okay, 3146. Now if we do this 3145 plus 3146, okay, now this is our equation. If we do this, then our result will be 1, so we'll write here 1. Similarly, we will find all those value of the letter a, w and p. We'll get here 16, here 16, here 12, and here 5. So now we get all index value between 1 to 26. Now we just need to write down all value of those index. So for 1 it is A, for 16 it is P, which is this P. For 16 this is P, for 12 this is L, and for 5 this is E. So we get apple. So we can identify that after the conversion of ciphertext into a plain text, we get apple, which is the message we initially began to encryption here. Here we encrypt this apple keyword and we get this LAAWP as ciphertext. Then we uh, use this ciphertext and decrypt this message and we get apple as a result.